Hey everyone, this is Daniel Faruk, the JVM, and what you're about to watch or listen, depending on where you are, is a long-form conversation with James Ward. He's a professional software developer since 1997, with much of that time spent helping developers build software that doesn't suck. These are his own words. He describes himself as a typed, pure functional programming zealot who often compromises on his ideals to just get stuff done. He's the author of several programming books, the latest of which, Effect-Oriented Programming, is the subject of a good chunk of this conversation. He's a frequent conference speaker around the world, and he's been recognized as a Java champion in 2021. He's currently a developer advocate for AWS, and he's also the co-host of the programming podcast Happy Path Programming. And we cover a lot in this conversation. We cover effect-oriented programming and good mental models or abstractions, functional programming, Java, Scala, Kotlin, and about a dozen other esoteric languages that James has been exploring, speaking at conferences, software engineering in the age of AI, and how to help LLMs write better code, and a lot more. So without spoiling too much, here is a long-form and wide-ranging conversation with James Ward. James, it's good to see you. Thank you for making the time. Welcome.
Yeah. Thanks for all you do to help developers learn things. So I'm excited to chat with you.
I hope I'm going to do more of this, and this is part of why I wanted to have this conversation. So thank you for contributing to it.
Awesome.
So I wanted to start with your latest work, which is effect-oriented programming. There's a lot to dig into the book, but one first thing that I wanted to ask is why effect-oriented programming? Why this particular topic?
Yeah, I think it was kind of a journey for me. I got into Scala. It's maybe been 10 years or something. I still feel like I'm a novice in Scala, but I got into Scala and was doing programming. Initially, I was writing my Scala like I wrote my Java, and so I didn't even understand what immutability was. Had just no idea like what the benefits of Scala really were. You've heard it called like Java without semicolons,
Yeah.
and that's where I started my journey with Scala. And then I got into more functional programming, and so started to learn some of the functional programming stuff. And as I got deeper in, and even like going through the path of building things based on futures, and then getting into Scala Zio, like going down this like journey into functional programming, I just realized like how much more productive I was when I was doing functional programming, and how much better the quality of software that I was producing was. And I became a total believer in functional programming being something that could really help us create higher quality software more easily. And that was kind of you've probably heard my podcast, Happy Path Programming, but that became kind of the theme of the podcast, not in every episode, but in a lot of episodes, was like, how do we make building better software easier? And I think for me, effects became this like next big improvement for how we can do exactly that. How can we make like lower the bar, make it easier to build higher quality software? And so Bruce and Bill and I, my co-authors on effect-oriented programming, we went through a long journey to get to effect-oriented programming, but it kind of was that same journey where we were like, Bill and I were convinced that Zio was a great way, and we wanted to teach people about it. But it took us 4 years of working on the book to get to the finished version. But the first 2 years, we weren't writing effect-oriented programming. We started by writing a Scala 3 book, and then we switched to writing a Zio book, and then we switched to effect-oriented programming. And so it was kind of this like similar journey where we didn't intend to from the beginning set out to start a book on effect-oriented programming. When we started writing the book on Scala 3, we were like, Bill and I were like, we don't really want to show like the things that we don't think you should do, like futures. We want to show like the way to more easily build better, more high quality, more reliable software. And so we're like, well, maybe we should write a book on Zio. And of course, like Zeonomicon and so many other great content already exists around Zeo. And so we're like, what unique value could we bring here? And then it became pretty clear that the concept of effect-oriented programming is one that many developers still don't know, but has so much value to creating more reliable software that it's like, yeah, we should just help more people get into effect-oriented programming. And so, yeah, that's the long story there.
This is interesting because I didn't know that the book was not uh, did not have that target from the outset. It was a Scala 3 book. What was your intention at the beginning? I mean, were you targeting the functional programming mindset, or what was the original target?
So we the original one was actually that Bruce had written Atomic Kotlin and
Hmm.
had written a book on Scala with Diane Marsh a long time ago. Even so, his Scala book that he wrote with Diane Marsh came a long time ago. Then he wrote Atomic Kotlin, and so the initial thought was that we would basically write Atomic Kotlin for Scala and for Scala 3, and that we Bruce and Bill and I wanted some project to work on together, and that just seemed like an easy target. But then as we started drilling into it, it's like, yeah, in Scala you can do immutability. And Bill and I are like, we do not want to show mutability. Like, but if you're writing a Scala 3 book, you probably got to show some of the parts that I wouldn't recommend people actually use. And so, like future. And so so that we got to that tension of like we don't want to write a Scala 3 book because we don't want to teach people the less good ways to do things than Bill and I know. And so, yeah, so that was a kind of weird journey into it.
I mean, it's an exploratory journey, and it's a normal part of a creative project. I mean, it's not uncommon to start with one goal that you think you have clear in your mind, but as you develop it, it morphs into something else because you find a more important topic. Uh,
Yeah.
and it seems that this is the case for this book, and it's certainly the case with my own courses because many of them either did not see the live, still do not see the light of day, or they morphed along the way. So
Yeah.
even some of my own courses on the effect systems like Cat's Effect and Zio and stuff did not start out like the finished version, of course.
Yeah.
So.
And then we also, and I think you've probably seen this too, we identified that there isn't a lot of content out there that helps people really understand why they would want to use an effect system, what value it brings, the high level concepts. And so a couple years in was when we were like, oh, like that's the gap that we can uniquely solve. Like you can read Zeonomicon and understand Zeo. We didn't want to write another Zeo book. We figured you and John DeGoes and others have covered that space pretty well. And so we were like, what the unique value that we think we can bring here is to not talk about Zeo really. Like
Mhm.
Zeo happens to be the implementation. We will instead teach people the concepts of effects and effect systems and the values and the why of effect systems. And so that became the focus. And it's a pretty short book. And we do want to work on other versions of it. Like I would love to do a Keo version. I think Keo is awesome. And it should be so we wrote the book with the intention of being able to take all the code and swap all the code for some other effect system and not have to change a whole lot of the prose around it because the concepts are really trying to generalize to effects and not be specific to the implementation of Zio.
That's the thing that I appreciate most about the book. I've checked out the book, and the concepts are more of a mindset thing than the code or the particular effect system details or the particular aspects of it. It seems pretty easy to swap, for example, Zio with I don't know Cat's Effect, and
Yeah,
the concepts will pretty much stay the same. I was curious
yeah,
why you thought this was an important topic. I mean, the reason I'm asking is because when I go to conferences, especially like mixed programmers, not just Scala conferences, but also with Java programmers, Kotlin and stuff, uh, I get this. I mean, I get into conversations with people in different ecosystems, for example, in Java and Kotlin, and I find myself in the position of pitching Scala to them in the sense that the question that comes naturally is why should I use Scala rather than Java or Kotlin with all these mature ecosystems or mature libraries and stuff. And the kind of phrase that I came up with naturally in conversation with these people was something along the lines of what you said, which is the ability to write safe software quickly and conveniently. So it's like a mix between safety and convenience.
Yeah.
So I was wondering how much, or if you had a similar positioning or a similar realization when you came up with the idea for the book, because from the amount of work
Yeah.
that came up into the book, like 4 years is a long time, so it must be an important topic. So I was wondering how you thought about that.
Yeah. Yeah. We actually, before it became effect-oriented programming, the concept of the book was essentially that we were saying like safety and convenience. And I forget, we may have it written down somewhere in a Git repo, but the draft book title was something like reliable, or building reliable something, productive, like it was taking those ideas that you're talking about, and then we're like, oh, effects are the thing that really enables this, uh, really enables many developers to kind of take that next level of the productivity and the safety, and the testability and the refactorability, like all those things that developers do all day every day. Like effects is just a better way to do all of that. I have some challenges with Scala being maybe I don't think that Scala is necessarily the best way for your normal Java programmer to get into the world of effects, and it's kind of yet to be seen what will be. TypeScript effect, I think, is a great option for a lot of people because there's millions of developers that use TypeScript, and the fact that Zio was basically ported to TypeScript in the effect library, I think it is the biggest opportunity to get the masses more into this world. For the Java and Kotlin developers, I I'm not totally sure what the best options are for them. My hope is that there will be a good effect system that emerges in the Kotlin ecosystem. I don't know when, if or ever Java will have something that would be something I would recommend in that space. But and the Java ecosystem is largely very far away from the concepts of safety and refactorability and all the functional programming stuff, basically. Maybe taking small steps in that direction, but yeah. So I think all that to say, like yes, the goals, after we shifted out of the idea of creating the Scala book, the goals became, how do we help people create better software more easily? Exactly what you're saying.
This is very interesting because it seems anecdotally that people that adopted this mindset do describe their own code as being safer and their experience more, let's say, clear. That it adds clarity in the process of writing their code. So it seems that effects are a sweet spot for uh, this sort of, let's say, safety and clarity kind of mix. So, if you could describe to people, because not everybody knows what effects are, if you can describe to people what effects are, what their main characteristics are, and why they're important.
Oh yeah, good question. Um, yeah, and it's good to probably talk about why effects. I should have reread our why effects chapter in the book, because it's a hard concept to explain, especially for someone that's not familiar with functional programming and stuff. So let's start with let's and my answer isn't as good as Bruce's. Bruce is really good at taking these complex ideas and distilling them down into simple ways to explain things. And I tend to go more into the technical things, or that's not the right way to say it, but I'm not as clear and concise as Bruce is at describing some of these things.
Maybe
So
we can
probably
refine the definition as we go along here.
yeah, there we go. We can work on it together. So here's part of the way that I think about it. One of the biggest challenges with creating good software is that we often aren't able to do I think it came from Haskell, the make illegal states unrepresentable thing.
Okay.
And this idea is that if something compiles, it should work as I intended. I shouldn't be able to compile something that allows an invalid state to exist in the system. And this is the source of production bugs, is that, oh, something happened that I didn't expect to happen, and I didn't have the right code to deal with that situation, and so now I have a production bug, whether, in the simple form, like a null pointer exception, like, oh gosh, I forgot to check this possible null thing. Um, and so there's many different levels that you can go to make illegal states unrepresentable. Nullability being kind of a low-hanging fruit that Kotlin really is taking advantage of. A lot of people use Kotlin because, oh great, we get nullability just like built in. And that is a make illegal states unrepresentable kind of thing, because now in the type system you represent this thing can be null or not. And that just eliminates a whole class of potential null pointer exceptions in your production system, where it's like, oh gosh, I didn't think about the fact that this could end up being null. And in Kotlin, you're like, it's going to tell, the compiler is going to tell you, it's going to tell you that you have to think about those things
And it was an
if you're
amazing
working
decision at the
with the
time at
nullable thing.
the introduction of nullability.
So there's many different levels that we can go through to make illegal states unrepresentable. The going nullability, I think, is an easy one to grok. Um, the next level, let's go with typed errors. So uh, the next level in related to effects for making illegal states unrepresentable would be that we have errors that can be produced from something. Likely you're talking to a database, it's like, oh, can't make a connection. And another source of typical production issues is that we imagine that these errors can't happen. And so, oh, we can't make a connection to this thing, or something timed out, or whatever. Um, we like to go on this like naive happy path and imagine that those air conditions can't exist, and so we ignore them with exceptions
At our
is
peril.
one of the common ways, at our peril. Or in the case of Go, it's just oh, you have to check for the existence of this error, but then most people just ignore it anyways. Like, it doesn't, there's often not the air handling becomes something that is not helpful to the developer to deal with the situations where things can unexpectedly go wrong. It just becomes an annoyance, and so I ignore it. And I think we can see this with what's the exceptions that in Java that you have to handle. That's basically the name on that one. Checked exceptions. So checked exceptions, probably a great idea, because it then forced people to have to deal with the possible error states that something can get into. The problem was that they weren't really part of the type system. Like, they weren't expressed through the types in a way that led to composability, to the ability to refactor things. Like, if you have a method that throws a checked exception, you can't put that into like a map function, and like, not
Yep.
like, how do you even handle that? And so what we want to do is make it easy to handle the cases where something can go wrong. And so in effect systems, one of the things that it represents is the possible errors that can come out of any given call, but without sacrificing the composability of a system. And so that's oftentimes where it's like you can come up with other error handling models, whether it's exceptions or whatever. But until you get to the ability to have something that represents these error situations that still composes, uh, that's one of the great things about effect systems. So I'll pause there and see if you have anything to clarify or add to that piece.
All right. So it seems that effects are these data types that kind of encapsulate the possibility of something unexpected happening or the possibility of something else other than a pure computation happening. So the way that I think about it and the way that I share this my with my own students at in my Cat's Effect or Zero courses is that an effect essentially describes two things. One, it describes the value that will be produced by the computation on the happy path, and two, it will describe just by its type the potential other things that may occur as well, other than the computation. Or so the potential
Yeah.
error that might be happening, or the potential side effect that is the other um, phenomenon that may happen in the real world, other than the computation of that pure value, and that type is the effect. So we say that that particular type is an effect because it may produce uh, other things, or may other things may happen other than the computation of a value.
Yep. That's great. Yeah. Yeah, exactly. Yeah. So I guess I lost track of saying how this all relates to effects. You did a great job with that. But yeah, so it's having a way to represent these computations that can produce a value, but also can do something else. And so the air condition is one of the something else's that can
Yep.
happen, but then there are other things that are related as well. And so then the next thing, at least in the land of Zio, is the dependencies that a given effect will need. And so again, we can represent that in the type system. So we get the make illegal states unrepresentable thing. And then anytime we call something that needs a dependency, like a database connection, we can then provide that into the environment. And if we forget to do that, the compiler is going to tell us and not let us actually compile our program. And again, this in the world of Zio, and maybe all effect systems, maybe at least the effect systems I've worked with, we're doing this without sacrificing the ability to compose things, because oftentimes our systems are just a bunch of side effects that all have to figure out how to work together, and potentially work in parallel, and potentially work in some sequential form where different effects can produce different errors and have different dependencies. And like, how do we weave all that complexity together? And by having an effect system, one way to define these computations that can produce errors have dependencies, and we can talk about other models for representing effects, but at least those things, how do we bring all those different pieces of the application together? And then we get some great benefits. We get the ability to have a kind of universal model of things that can fail, things that have requirements to be able to run. So then we can, on any effect, do something like a dot timeout. And dot timeout then doesn't become some weird thing that, like if you've got some non-effectful system, it can actually be really hard to figure out like how to do a timeout well, because then that introduces a new possible error type. And so just adding a timeout to a normal non-effect program can be really hard. When you're in the world of effects, you just say dot timeout and put the however you want to specify your timeout on it. Retry is another one, and I love retry because uh, many mature libraries that are effectful libraries, side effecting libraries, usually will have their own way to do a retry. Sometimes it's internal, sometimes it's there's some DSL on it, but retry is actually a complex piece of machinery, because how do you want to manage the actual retry scheduling? Do you want to be able to do like exponential back off? How many do you want to have a max number of retries? And then do you want to allow retry on something that won't actually produce an error? And so this is where, in the world of Zio, you get the dot retry on any effect, but you get all the you can add a retry to anything, except that you can't add it to an effect that won't produce an error. It actually won't let you do that. It's a compiler to try to do a retry on something that won't produce an error. And
So
so
essentially,
it
the type also describes the kind of error that would be produced, and just by looking at the type, the compiler won't allow you to do that.
Yeah, exactly. Yeah, and the fact that you can then add retry onto any side affecting piece of any effect that you have is just except for the ones that don't produce errors, becomes this like amazing thing where you don't struggle with it like you would in a normal application that's not representing the side effects, not representing the errors, not representing the dependencies, not representing initialization becomes initialization or what you want to do when you close something. So the kind of open close stuff. Effects give you the opportunity to do all that in a reasoned way. And then we call it the like superpowers, or one of our first chapters is like trying to illuminate some of these superpowers that once you get into the world of effects, then you just get all these superpowers for free. And so adding retry to an effect is just dot retry. And you can then give it a schedule or max number of times or whatever.
This,
So yeah, it really opens up a lot of problems become really easy once you move into the world of effects.
what do you think uh, a programmer could take away in a few minutes from the mindset of effects? And the reason and the reason why I'm phrasing the question in this way is that for many developers, the concept of an effect system, at least when they look at it at the first at first sight, it might seem a bit overwhelming or it might seem a bit complex. If they look at the type signature of Zio, they see all these type signatures with variants annotations. If they look at Cat's effect, they see either an IO data type that can do pretty much everything, and it seems like a god kind of effect, or they look at the tagless final pattern, and that's particularly daunting to
Yeah.
even experienced Scala developers. So if you could give people like a couple of major ideas that will be tremendously valuable to their progress or their career by studying effects, what might those be?
Yeah, it's a good question. I think this is one of the challenges that we have is w- effects can be a large leap for a lot of people and can be an astronomical leap for many other people. So, if you're in the world of Java and Spring, to get to a good effect system, you're going to have to it's a very large leap to go from the world of Java Spring to a good effect system. There's a lot of knowledge that needs to be obtained. If you're doing Scala and you're doing future-based programming in Scala, then it's a much smaller leap to the world of effects because you can even shove Zio into, or I'm sure Cats Effects has this as well, where you can shove it into a small piece of your application and start to get some of the benefits of effects, and then still turn it into a future, and so it still kind of fits within the API structure that you have. Um, so it depends maybe on kind of which trajectory people are coming in through it to figure out like what's the path to effects for people. Um, so maybe back to your question of what um, what would be the best way for somebody or the biggest benefit of someone getting into the world of effects? Like, why am I going to take a small or a very large leap into this world? Why would I do that? And it's It's a really good question. I mean, the air handling one is an interesting one because just immediately you get a lot of benefits, but you don't necessarily need a whole effect system to do that. You could just use an either and or there's different ways to represent that just that piece without going to effect systems. So I don't know. What do you think? What's your kind of path or benefit statement there?
The way that I try to explain this to people is that, especially in the important code, it's really hard to reason about the kind of things that can go astray, not necessarily wrong, but in unexpected ways. And so effects are good descriptions of the entire thing that you are writing. So an effect is essentially a description of a program. And that program contains with exact clarity what it produces, when, the kind of stuff that happens within that program, and then that program is just a data structure because an effect really is just a data structure with a type attached to it. And then you can pass that program around. You can pass that as a data structure everywhere, and you can combine it with other programs to complete bigger programs. So suddenly, if you start to think in terms of these effects, the code that you're writing starts to become more like Lego pieces rather than lines of code that you need to reason about, especially in concurrent systems where the state of the system at any point becomes very important. As you said, with retries and timeouts, these are two very important patterns and that occur a lot of times in production systems, and especially in the important code where you have to get a particular resource at that particular time. At Disney, you have to get a particular frame at that particular time. Any errors must be handled at that particular point, and so on and so forth. So, for the important code, for the critical piece of your software, it's very important to be able to compose your programs in terms of these descriptions that you can combine. And effects are a good representation of what it means to have the description of a program that you can stick together in patterns that you find valuable, rather
Yeah.
than thinking about the nitty gritty of let me manage the retries, let me manage the time, let me manage the thread, let me manage the whatever resource for opening and closing and stuff like that. So
Yeah.
effects are a good encapsulation of what it means to have various mini programs or mini patterns in your code that you can replicate, that you can pass around, that you can repeat, that you can combine or modify as your code becomes more complex.
Yeah, I love that. And there's two other outcomes that are really valuable because of this. The first one is the refactorability. I think John DeGoes calls it the fearless refactoring or something. The fact that you can, now that you've got this model, that this Lego like model, you can take a piece, refactor it out, and have really high confidence that the system is still going to work when those Lego pieces are put back together, composed together. The things are still going to work as you expect them to. So the refactorability becomes something that's great, huge value. And then the other one is the testability, because now that I've got an effect that represents the side effecting pieces, the dependencies that the thing needs, now it becomes much easier to write sane tests for that thing instead of, I think generally with complex side affecting systems, we just like give up on writing good tests most of the time because it's too hard to like unravel all the layers of side effects. And now, because we've been able to break things into pieces, we can test those pieces independently, and it becomes much easier to potentially provide just the dependency or service that something needs to a given piece and test it in isolation without having to use mocks and fakes and some of those things. So yeah, so I think the refactorability, the testability, become two things that are not like immediately evident to effects being improving those other kind of tangential things in such significant ways. But yeah. What do you think about the refactorability, testability, and then anything else on it would be like ilities or something around effects?
Yeah, I mean, these are side effects, pun intended, of
Hmm.
using an effect system or using effects as a thinking process to organize your code. And the refactorability is a natural extension to the description of the program kind of mindset, because you get these kind of mini pieces that you can combine. And when you take a piece out and then you modify it, and if you keep the type signature intact, you can stick it back into the code and you get the modified behavior, but with the guarantee, at least that's by the type description, that your program is still going to work, but with the extra things that you've added or that you've changed along the way. Or you can take
Yeah.
groups of programs, or you can take groups of effects, combine them, swap them for a different pattern, stick them back together. And for integration testing, as you said, if you have a complex program, you can take a piece of core uh, module out, replace it by a testing environment, and then the entire logic of your big software becomes very similar to what you would see in production, but with the instrumentation or with the extra maneuverability that you get in tests, so that you can verify that the code works correctly. So
Yeah.
the composability aspect is very important. Yeah.
Yeah. And then you mentioned concurrency, and I think we should talk a little more about that because Zio, I think, still kind of pitches. It's one of its like primary pitches for why Zio is concurrency, and there is a ton of benefit to using an effect system when you're dealing with concurrency, because it kind of puts you into a constrained model of concurrency that allows developers like me who are not like Victor Klang to actually write concurrent code in a safe way that I'm much less likely to get into deadlocks and other issues that are common in concurrency. And so certainly if you have a bit of code that is concurrent and like really complex state management with concurrency, effects should definitely make that piece of code a whole lot more easy to reason about and get right. But
Yeah,
is
I
that
mean,
true?
I definitely agree with this, because writing concurrent code is hard, really. I mean, there's no way around it.
Yeah.
Writing important concurrent code with clear safety guarantees is very difficult. And
Yeah.
unless you have a lot of discipline with it, you can get burned very easily. At least when your product starts meeting the customer, you'll definitely get into states that you haven't thought about. And so
Yeah.
you have to be kind of like an expert programmer with a lot of discipline to be able to manage concurrent code in the, let's say, so-called manual style, in the style of Java, or in the style of the more mainstream, or let's say bare bones concurrency models. And an effect system is, because it's a description of a program, that description of a program can be of a certain kind. So it can be, for example, of the kind that is able to modify a certain piece of state uh, with concurrent access. And because you have that Lego piece with these properties, you can swap it around and you can replace it with something that's sequential, or replace it with something that's uh, concurrent. And you get the same kind of safety guarantees, and you don't need that much discipline to be able to write correct code, but rather just focus on the piece of logic that you're interested in, whatever your application may be, and the effect will take care of itself, because the scheduler internally takes care of all the bits and pieces that you would normally have to take care of if you would write that kind of code yourself.
Yep. Yep. Definitely. And then you get this like side effect of, oh, you have this complex piece of concurrent code that's using all your cores to the max, and that's all great. But then how does that then fit into a larger system or more complex system with, let's say you've got this concurrent piece and you want to like add a timeout on it. Well, then you just do that timeout and boom. It's an effect like anything else. You get all those benefits, but you can kind of constrain the complex pieces to a given effect and then wrap that with other effects and get all these benefits. But then there's one of the places where I've seen the benefits of an effect system really exposed, and this is, I think, the last chapter of our book, is you get into libraries that then provide higher level abstractions over this stuff. So there's the library resilience, which adds bulkheads, circuit breakers, all sorts of kind of then higher level functionality
Yep.
in an effect system around Zio. And it's like, oh God, doing this like complex bulkheading or rate limiting, which requires managing concurrent state. The fact that I can just like in a few lines of code add that kind of functionality and get all the benefits of an effect system that we've talked about, but with these higher level concepts, like then it's like, oh, okay, the fact this really was like this like Lego structure where I was able to take these small pieces and compose them into larger pieces and then wrap them with these complex rate limiters and bulkheads and that sort of thing, and it's still an effect, so that just becomes composable with other things. So yeah, I love that the resilience library in particular really illustrated the benefits of building out to more complex scenarios as well.
Yep. So for everybody listening or watching, if you haven't tried effects, I both of us recommend at least diving into the mindset to see how this fits your how this fits your mind. I wanted to ask.
One other thing, real quick, before we move on, is I did want to mention streams because I was thinking about what are some other areas where people can get like quick wins on effects, and streams is one of those places where like the Zio Streams library, if you're doing any kind of stream processing thing, whether it's, you've got Kafka or whatever, like this becomes a place where effects have so much more value because you get this really nice API to deal with the things that you normally need to do in stream processing, but it still is all built on effects. And so I think streams can be one of the places where people can get a quick win on
A quick and
an effect
powerful win,
system.
really,
Yeah,
because
super powerful.
it's really easy to abstract powerful patterns that would otherwise be very difficult to write if you would do this manually or if you do this yourself.
Yep, yep.
Yes, so I wanted to ask. I mean, you've seen a lot in your career. I mean, you have an almost 3 decade career. You have more years of software engineering experience almost that I have years of life. So you you've seen a lot, and you've seen a lot of patterns. You've seen a lot of mental shifts in software engineering. I was wondering if you have some memorable experiences where you had like these changing of mindset for yourself as a software engineer. It seems like, for example, this effect-oriented programming mind shift is one of them. I was wondering if you have others as your career progressed.
Yeah, it's a good question. I think I have had a number of shifts. I think the general functional programming one, which came uh, a few years after I got into Scala, I started really making the shift to functional programming. So, and that started with just immutability and pure
Hmm.
functions and those pieces of functional programming. And so that was a huge one because I most of my life as a programmer had done the typical imperative style of programming, and so functional programming, it took me a while to kind of wrap my head around it because I spent, as you said, decades like as a Java developer and writing, not having no concept of a lot of
Hmm.
the concepts of functional programming. So that was a huge one. The other, yeah, other mind shift switches. Uh, there's been a lot. Functional programming is definitely the biggest. Oh, types. Let's talk about types because
Yes.
uh, I I I went. This was now a long time ago that I shifted to types, doing statically typed languages. But there was a huge shift for me in that because I early in my actual career, I was doing Perl, Perl CGI, and then PHP, and then I got into Java. But I didn't really understand types and type systems and the value of all that until I read Bruce's book, Thinking in Java. And then I was like, oh, okay, like that was the first inkling that these types are a powerful thing that, when done well, should actually make my job as a programmer easier,
Hmm.
because now I can have a compiler that's going to tell me when I've done something wrong. And so I think this was a huge shift for me. Maybe to your audience, like, people are already convinced on that, but that was for me a huge leap forward. But then many years later, in the world of Scala, then discovered, like, oh, there's many more layers to what we can do with types, and effects being one of those. But there's many more layers that bring us value. And so the kind of generic programming, using generics, to further constrain things, again, became like, oh, I can use these things in a type system to help me as a developer be more productive. And yeah, now types, and we could get into type classes too, but these ways to have the compiler help me help me write better code faster. It just became this, like, of course I want to do that. Of course I want to leverage the type system in the best way possible. So, an interesting side note, I've been learning TypeScript and the effect library for TypeScript, and as part of that, dove in to structural typing.
Hmm.
And structural typing became one of those things where I'm like, I'm not sure that I'm really like getting the benefits
Seems like a
of
mix.
having a compiler there. And so that was an interesting one where I'm like, okay, there are other ways to manage types and deal with them. And structural typing, I'm not sure I'm like convinced that it's a better way that really like leaps me forward, like the Scala type system. Like, I love the Scala type system, and it's one of the reasons why um, I when given the choice, I write a lot of code in Scala, because I love how much I can use the type system to express the intent of something, and then have the compiler tell me if I'm wrong, basically.
Did you ever feel that it hinders productivity? There's one criticism of type systems that it's somehow that a very strong type system or a very strict library written around a static type system may hinder productivity because you have to kind of conform to all these types and then you have to conform to all these shapes. But then it's easy to write things in JavaScript and do like dot field where that field is a part of a huge a huge object and stuff, and they feel that they're going faster. Did you ever feel a hindrance in the speed at which you developed code?
It's a really good point, because yeah, absolutely. Like, you maybe this is best summarized by something I heard John DeGoe's tweet about a long time ago. He was talking about gradual typing, and the idea of gradual typing is like, yeah, I can kind of use types when I want to, and I can, not have to deal with the pain of types. Now I can gradually adopt them. And his tweet was something along the lines of, so that you could. It was making fun of gradual typing by saying that the downside of gradual typing is that you're going to then gradually in production find out about the problems with your program, instead of finding out about them at compile time. And I think that is exactly right. There is some uh, added time in development when you're working with types, because then you actually have to think about what is the correct representation of this thing. And sure, you're not going to be able to get to actually running your program uh, faster, like, but you do know that when you get to running it, it's going to actually be correct, instead of gradually running the thing over and over and over again, hoping that you get it right, and then never refactoring the code, because if you refactor, all of your iterative loops of running your program, all of that all of that is just destroyed instantaneously, because you no longer have the type system to validate that it was correct.
And
And
you kind of
so
have to recheck again whether your program is correct.
that's right. Yeah, so I think there is overhead, certainly, to having to specify types, and I certainly struggle sometimes, like with I will spend time beating my head against my desk trying to figure out how to represent something with types, and maybe it doesn't feel as necessarily fulfilling as the YOLO Python. I just run the thing, and
Hmm.
it's a script. So like whatever. I think there is some like brain chemistry benefit to, like, oh, I ran the thing, and oh yeah, then I found the error. Late happened to find the error later. Like, there is some dopamine benefit to that, and so it is sometimes hard to figure out what is the right typed representation of this thing. But the nice thing is that I iterate on those types, and then as soon as the compile works, I'm like, sweet. Like, I don't
You have
have to
confidence, yeah.
worry that exactly right. You're just like great. I did the work in the types, and now I have confidence when I'm the compiler validated that this thing is actually going to work as I intend. So yeah, I think for me, and there's many different ways to kind of represent things in types, and that's where it gets a little tricky. Is what's the polymorphism, the general term of polymorphism for generics? Like, I just like there were so many.
Or parametric
Yeah,
polymorphism.
parametric polymorphism. Thank you. So I didn't even know about like different types of polymorphism, and not even that long ago, because I was so used to the world of Java and inheritance being really
Yep.
the primary polymorphic type, and then it's like, oh, there are other ways to do polymorphism, and generics then become just another tool in the toolbox for polymorphism, essentially, which is not generally how they're used in Java. um, they're I don't know, I guess a little bit, but not in the extent that in the world of Scala we use parametric polymorphism or generics to help us represent things in a more complete way, so that we have confidence when the compiler runs. Great, we're pretty confident this thing's going to work.
Speaking of type systems, how do you have experience with Scala, obviously with Kotlin, with Java as well? How do you compare the type systems of these languages, and if you have a sort of type system that fits best with your mode of thinking?
Yeah, I mean, for me, I love Scala's because it is complete in terms of what the it has all the like things that I could possibly need in a type system. And if
It's going to get more, by the way,
yeah, that's right, with capabilities
with
or whatever
capabilities.
we were
Yeah.
calling it. Yeah, yeah, yeah. So and of course Martin is amazing. I haven't watched your interview yet with him, but I'll have to check that one out, because he's amazing. I mean, he's been working on type systems for what, like 40 years or something.
Yep.
Like it's just, he is genius. I love the like dot calculus stuff. I love the relative soundness of the type system in Scala. Like for me, like Scala is a really amazing, fantastic type system and has so much power. So, but so certainly Scala, my favorite. Kotlin, the biggest thing to Kotlin that they did, which we talked about a little bit, was the nullability. So to put the
Hmm.
nullability in the type system, um, it has a trade-off, and I'd love to hear your thoughts on this. It's really nice to have a simple representation of nullability and have that built into the type system. But one of the downsides to that is that it's not generalized in a way that could be beneficial. So, just as an example of this, in Kotlin, because they've built nullability into the type system, if you've got a nullable type, you can do the question mark
Hmm.
to chain operations,
Yep.
null chain the operations together. But that question mark only works for the nullable types. When wouldn't it be nice to be able to like chain other types of things together, maybe effects together? Like, oh, my effect was successful. Let me chain it onto another effect. Um, but but this was really just a specialized case for nullability in the type system, when if you look at the world of Scala, there isn't a generalized nullable type, because you can represent that with an option, but then you don't get some of the ergonomics that you get in Kotlin for nullability being in the type system. So I don't know if we've fully like gotten to this like nirvana of balancing this like pragmatic, like what Kotlin has with nullability, with the more generalized solutions like you can do with Scala and Scala has. So I don't know. What are your thoughts on the trade-off between the generalized versus specialized things like that?
Well, Kotlin is definitely hitting on a very common pattern, and they built into the language something that happens all the time with relatively little effort. So I'm pretty sure that they did like an 80/20 analysis of what is the most, let's say, the most widespread
Biggest bang
source
for the
of
buck.
errors. And they
Yeah,
just like hit one, and they covered a bunch, like half of a programming errors, like just null pointer exceptions. And that's
yeah,
built into the compiler, and that's a major win for them. Scala went all the way, really, with and it's not even there yet. I mean, with the capability tracking and the ability to abstract away resources and uh, access to powers and within the type system itself, it's still uh, in development. But Scala chose a way that is the is a very general one, but then you have to fit your mind to that particular style. I mean, in Kotlin, it's very easy to say that question mark dot and then call a method, and the compiler just takes care of whether that thing is null or not. And then if it's not null, then it will call the method. But in Scala, you'd have to write like a tiny bit more code to be able to take care of that particular case. But then you have many, many, many different tools for other kinds of things, not just like a generalized version of nulls. You have union types, you have eithers, you have options, you have effects, you have various kinds of um, composability between the different kinds of types that you can have. So, for example, um, because we spoke about effects, option is an effect because it returns a value if it has something, and it might return null if it doesn't. So it's the type describes the kind of value that it will produce, and it also describes the potential side effects that may be produced if need be. Either is another kind of effect. IO from Cat's effect, or Zio from the Zio library, or uh, composure of Zios and stuff like that. All of those are generalized versions of what you can obtain, and the other things that may happen as a, let's say, I want to choose a different word other than effect, as a phenomenon in the real world,
yeah,
uh, other than computing a pure value. And
yeah,
if you want to work with these kinds of values, you have to conform to a specialized API. You can't just call a method on the object that a Zio returns. You have to call map on the Zio first and then call the method inside of it. So you kind of have
yeah,
to fit that into your mind rather than just going into the Java kind of mindset and just add a question mark and then you're done.
yeah. There's one other piece to this that kind of brings together some of these concepts, to unite the like type systems and power of type systems with effects, which is ADTs. And Scala 3 does a great job of representing ADTs, some types, product
Yeah,
type,
there's algebraic data types
algebraic
for
data types. Yeah. And
for
so where this then brings you some benefit as a developer in this world of effects is let's say I've got a effect that can fail with a user not found error, and I compose that with another effect that can fail with a I don't know, cannot connect to service error. When I compose those two effects together, the error type of my new effect is then a sum type of
Mm-hmm.
those two things. And then what's awesome is I can then pattern match on in that effect handler, in a handler for that effect, on those two things, and can get an exhaustive check. So the compiler can actually tell me, I can actually turn on a mode, which I usually do in Scala, which will actually fail if I don't exhaustively check for those two types in a pattern match. And so then I'm like getting this benefit of this great, complex, powerful type system with effects that help me compose and help me make sure that when when the code compiles, I've now covered the possible ways that this particular thing can fail, and the compiler is going to tell me about that. And so I love how Scala 3 and Zio really bring a lot of benefits together in this way that you don't really get. I don't think if you're in Scala 2 even, it's like the like exhaustive pattern matching on a
You don't
sum
get the
type.
union types because there are no such
Exactly.
things. Yeah.
Yeah. Yeah. Yeah. So and then just the ergonomics of it become easy to do the right thing, which is the concept that we're talking about is like, if I've got effects and I've got a powerful type system, then it should be easy to like write good code, and that's one of the ways that we see that kind of come into fruition with effects and powerful type system.
Well, hopefully more people can get the chance to explore FX systems because they're super powerful. I wanted to ask in your in the I mean, you've seen a lot of things. You've seen many languages, many tools, many libraries, many styles of writing code. Um, is there a thing or a mindset or a tool or a language, you can choose whatever springs to mind, that has aged particularly well, in the sense that it's been here for a while, let's say at least 5 years, maybe 10 years or more, and it has been relatively unchanged, and it has stood the test of time quite well. Does anything spring to mind?
It's a good question. I like to be like, where I like to play is more like on the fringe, where things are
Hmm.
moving quickly, where things are not likely to get adopted by the mass of developers, at least anytime soon. So I've been fascinated by things like Unison and Rock, which I I think there's probably little hope that those languages get mass adoption,
Hmm.
just because it's so much even further of a leap from, and if we're talking about like Java developers or TypeScript developers, uh, the the leap to Scala and Zio is a pretty significant one. The leap to like Unison and Rock is astronomically further. And so while I'm fascinated by those languages, I don't see that they're going to gain mass adoption. I think for me the thing that has where do we want to go with this? TypeScript is a huge contender in this like future space of enterprise developers, um, this more attainable way to like get a lot of these benefits that we've been talking about,
Hmm.
but for your normal enterprise developer. So I think that I'm thankful that the effect folks who created the effect library for TypeScript, not confusing at all that the library in the is called effect, but effect for TypeScript. I think that this is going to be a much kind of easier path for a lot of developers to get a lot of these benefits. Um, and I'm still just like new to TypeScript and learning it, but maybe to answer your question, maybe TypeScript is the place where things have been relatively stable. The language continues to evolve, but I don't think I've seen like a lot of breaking changes to the language. I think it's been
It's been
pretty
mostly stable
incremental.
throughout
Yeah,
the years. Yeah.
yeah, and for a lot of systems, you need that stability. Not you know a lot of the stuff I work on, I don't need to worry about having thousands of engineers writing massive production systems. I'm not working on anything that big and complex. I don't have to think about some of the same concerns. I get to dabble in weird languages like OCaml, and don't have to worry about larger, more complex things. So yeah, TypeScript is really interesting. I think the other answer to your question is, which isn't exactly a language, but I'm really fascinated by where WASM is going, and
Hmm.
think that it isn't it's evolving kind of slowly, but it is evolving, and so I'm fascinated to see, like, is WASM going to be this universal thing that actually ends up working this time, because we've taken many attempts at this. Java certainly
Yeah, the
taken
JVM
one
has
one
been
shot at this.
probably the most successful attempt at cross-platform development
Yeah,
in a couple of decades.
yeah, exactly. And so WASM could be the next thing, especially because it works in the browser, it works on servers, it has a good shot at this. And so we'll see where that goes. There still is um, some gaps to the world of WASM, and the spec communities are continually trying to evolve the specs. But I think WASM is super interesting for what could be a target output and runtimes for the future of developers.
This is super cool, and I find it fascinating that you know so much about the more niche languages like Unison, Rock. How do you stay relevant, or how do you explore these technologies or these tools, libraries, languages? Do you have a process for how do you explore it? Do you like to play? How does your exploration in these fringe mindsets look like?
Yeah, good question. There's kind of two sides of it. One side is Bruce and I have our podcast, Half Path Programming, and so through our podcast, we were like, oh, let's have Richard Feldman on,
Hmm.
because he's super smart and interesting, and he built this programming language called Rock, and we can just have him on and learn all about it. And so through the podcast, we get some initial discovery of some of these more fringe things. And Bruce and I both really like programming languages and talking about programming languages. So that's been one avenue. The other one is I think it was a couple of years ago. I wanted to come up with a way to talk about structured concurrency and
Hmm.
teach people about structured concurrency. And so I created this thing called Easy Racer, which is a collection of obstacle courses for programs to run through that are all kind of centered around structured concurrency ideas.
Okay.
And so I think I started my first implementation of Easy Racer was with Zio. And most of the scenarios or obstacles in Easy Racer are doing a race. It's like, how easy is it to take one thing, race it against another thing, and get the winner out? And
And
what's
cancel
the
the loser,
programming
maybe.
and cancel the yeah, and oh, definitely cancel the loser. There is an obstacle that actually does validate that your race does
Hmm.
actually cancel the loser. And um, so a race is it's a really nice, simple construct. And it's really fascinating to see how different languages and frameworks and approaches deal with all of the complexities to doing a race. And Easy Racer gets into scenarios like, what if we want to race 10,000 things all at the same time? How hard is that? And in the world of like Go, that's actually really freaking hard,
Hmm.
which is surprising because Go is supposed to be like this
Easy.
great thing for concurrency. It's so easy for concurrency. Turns out that that's not that easy in Go. Even Rust is another interesting one where there is a nice concise race macro in Rust in Tokyo. They're I don't know, it's concurrency, like the kind of the de facto standard of concurrency in Rust. So there's this really nice, concise, macro-based way to do a race, but it handles at most like three things. And so as soon as you get into, oh, I don't have three things, I have a list of maybe 10,000 things, you can't use the nice macro anymore. And then you have to get into, I think I had to use a multi-producer, multi-consumer channel thing in Rust to be able to like do the race with 10,000 concurrent requests. Anyway, fascinating and easy racer to see how do different languages and frameworks. So a lot of times I am able to use Easy Racer to explore a lot of these concepts of structure concurrency, and effects are part of some of those. So places where I can use effects, like I learned Keo by implementing the Easy Racer obstacles
Hmm.
in Keo, and that was a super fun way to learn that. Somebody contributed OCaml ones, which was awesome because we'd done a podcast episode with somebody on OCaml, so I was and tinkered a bit in OCaml, but then somebody came up with the OCaml Easy Racer implementation, and there's actually two of them. One of them uses their like algebraic effects, but the other one uses a library in OCaml. And this is actually one of the cleanest implementations of Easy Racer was the OCaml one, which was kind of fascinating.
It's
Uh,
interesting.
yeah. And so anyway, Easy Racer just gives me this really
Hmm.
fun place to learn new
So it makes it
languages
like
and
a test bed for your
frameworks.
for experimentation and for learning. Am I getting this right?
Yeah, yeah, exactly. And this one just happens to be, around structure concurrency because just there's some fun problems there, and it's
And
fun to
important
see
problems.
and important problems. Yeah. Yeah, it's like a race is I I use race all the time in my actual programs because of course I want to like do things concurrently, and sometimes I just want to race those two things together to get to a result faster. And so yeah, it becomes a fun place to experiment and learn and tinker with weird languages and see how they do things differently and frameworks. So there's Kotlin implementations. There's Java one. Java now has some structured concurrency stuff in Loom, and so yeah, lots of different things that I've learned by going through Easy Racer and trying to implement those obstacles with different languages and frameworks.
This is interesting. Do you ever use AI or LLMs for learning or experimentation when you try new things, or do
Oh
you
yeah.
start reading documentation and whatever?
Oh, I am very reliant on the AI now for especially areas that I'm not familiar with. If I'm working in Scala and Zio, I can just like bang out the code, and most of the code is concise enough because I'm using effects and I'm using
Hmm.
Scala that the thinking about the types and the operations on those types is something that I can just as easily and quickly do in code, and I think faster than it would be to do it in English. And so I can do my thinking
That says
in
something about
code,
the
not
FX
in.
systems, by the way.
Yeah, exactly, right. That I can productively think in code versus when I go into other areas that I'm not as familiar with or aren't as powerful, require a lot more boilerplate, whatever, then the AI is massively helpful for helping me quickly, get to code that maybe kind of works and is probably crap. I'm gonna have to rewrite it, because it's one of the fascinating things about the AI writing code for me. The way that I kind of see it is that it's trained on all this code that's out there in the world, and I don't write. I think there's like this gravity to um, I don't know, like generally bad code,
Hmm.
because
I wanted
most
to
of the
ask
code
about
that's
that,
out
but
there
tell me.
online is like not the code that I want to write. It's
Hmm.
like it's kind of crap. And so what I've seen from all the AIs is that they can generate code for you and be really helpful, but and help me get to like something that works. But then I generally have to rewrite the code because it's not written with the mentality that I want to bring to code, of all the things we've been talking about, is like, how can I better represent this in types? How can I use effects? Like I was just writing some Java code last night, and I like to use a var because in Java, because I don't want the type signature in both places. Like, it just is kind of silly to have it on the left and the right. This from the world of Scala and Kotlin. And so sure, it's great to like in Java now we can just say var and not have to specify it on the left. But generally the LLM is not generating that kind of code for me.
It's been
I
trained on
probably
the
could
legacy Java. Yeah.
like put it into like a system prompt, and like I probably could prompt it to do it, but the default from these LLMs is to write the code like is most existing in the world of
Yeah.
code. And so it's not giving me the necessarily the code that I want to write, which is kind of fascinating. But I think with MCP and some of these other things we can talk about, like, we're going to be able to manage some of those pieces. But yeah, so I think generally the AI code assistants I work at Amazon, and we've got this thing called Q Developer, and it has an IntelliJ plugin, and so I generally use that for my AI code assistant, and it's good. There's some nice things to it. They also now have a CLI, so if you want to do like the agentic stuff in a CLI, you can do that. And I've been playing with that. Was using that recently. This was kind of a fascinating one. Uh, there's this language MoonBit, which is kind of a WASM native language, and I don't. For some reason, I got triggered because they had this benchmark that was like, we're 8 times faster than Java, and I was like, huh, interesting.
Let me crack that.
Uh, yeah, let me see what's going on here. And so I didn't know MoonBit, and so I got the project, and took me a while to figure out how to get the tooling installed, because I don't do the curl pipe through bash thing. I just like disallowed, like for me, I'm not going to install your stuff through curl pipe through bash. So I had to like look at their install script and figure out how to like sanely install MoonBit. But anyways, got this thing installed, got MoonBit installed, got the Java application um, working, compiling and installed. And I was like, okay, what's going on here? Like what is this benchmark even doing? The benchmark was written in Rust, so I was using the AI to like help me understand Rust, because I'm definitely a novice at Rust. So I was using the LLM to like help me understand what was going on. But then I was like, oh, can I optimize this Java program? And so first I had to understand, okay, what's the benchmark doing? Turns out the benchmark is basically just benchmarking JVM startup time for the JVM version one.
Not the Java
But
program
then they
itself.
also had a Graal one, and the MoonBit one, native MoonBit was still a lot faster than the Graal VM one. Then I was like, that's curious. I want to understand more, like what why that could be. And so I pointed, in my case, the QCLI agent to the Java program, and I said, like, optimize this thing and run the benchmark, and just keep going until you get the Java Graal VM one faster than the MoonBit one.
That's
And so
fascinating.
fascinating, right? And so, like, which was super fun, because then I'm seeing like, oh, it's like, okay, we've got to like make this change to the Java code, and then let's test it, and then, oh, we're going to change the algorithm. This is doing a fast Fourier transform or something like that was
Mm-hmm.
the particular benchmark. So then I started tweaking the algorithm, and it was just, I'm just like watching this thing go and iterating. But what was funny was it's doing this, and I let it just run, and I have to like try some different prompts and all this kind of stuff. But I'm just letting this like agent like do this work, and it's trying all these things, and it it is making like some improvement on the benchmark, but not significant improvement. And so I then I'm looking at this and I'm like why, like this is GraalVM, it's native, like what is going on here? Why is it slow? And so then I was like, oh, profilers. We have tools in Java that make it easy to see what's going on here. And so I then run the Java application just on the JVM and the profiler, and IntelliJ was great. It's like, here's your flame graph. And it turns out that the actual fast Fourier transform piece of the program was like 5% of the overall
Wow.
execution time of the program. So it turned out the benchmark wasn't even like testing really the important thing. And the agent that I'd set loose on optimizing this thing, it was optimizing this thin little sliver of the execution time. So it turned out that the slow part that was taking like 90% of the execution time was that at the end of doing the fast Fourier FFT, it looped through the output and did a system out printf on it. And it turned out that the printf 16,000 times was taking up like 90% of the execution time. But what was
Surprised.
funny was that the agent didn't figure this out, and it took me running the profiler to figure it out. So both me and the agent were spending our time on this like thin sliver of optimization,
Mm-hmm.
and not the important part. So then I was like, what I need to do is write an MCP server that will run the profiler on something, and if I then provide a prompt that's like optimize this, the first thing that it should do is actually run it in the profiler to understand what the hotspots are, and I can implement that through an MCP server. And so anyway, I haven't built that yet, but yeah, it was a fascinating kind of path to where my brain and the AI's thinking both had kind of led in the wrong direction, because even I was like didn't even I was focused on the FFT piece of this benchmark.
Yeah, and you're hyper
um,
optimizing it, but the problem was elsewhere.
exactly. And so it was interesting that it actually took me a while to realize where where the focus needed to be, and thanks to the profiler it helped me do that. So of course we should be able to plug the profiler into our AI agent, and then it will have all that
Yeah, but you
information
have
and be
to
able
come
to
up with the idea to run the profiler.
yeah.
I
Yeah.
have two follow-up questions to this. One is, how do you think about MCP and how you think this can impact our own workflow as a software engineer? That's one. And two, it's kind of like a different question. You can take whichever one you like. How do you feel about the fact that essentially most of the code that we're ever going to read is going to be increasingly LLM generated?
Great questions, Daniel. um
You can combine them.
yeah,
You can take
so
whichever one you
MCP,
like.
um let's let's first talk about the code thing. So i I think that the LLMs, they're amazing tools, super helpful. They're kind of an indictment on abstractions. Like I think that the LLMs have basically said like copy and paste is a better way to write code than coming up with good abstractions. So I'm actually kind of disappointed with our whole industry that instead of like leveraging good abstractions like effects, like good type systems, we've basically just said like, like I'm just gonna have
Give me code.
a, yeah, I'm just gonna have a quicker way to copy and paste code, where I used to have to go to Stack Overflow and search through things and find the code on Stack Overflow and copy the code from Stack Overflow into my code base. Now the LLM's just like doing that in a much smarter way for me, but it still is like copy and paste. Instead of saying maybe our fundamental abstractions have been not awesome, and if we had better abstractions, then we wouldn't need to copy and paste so much code. And so this is where I still 100% believe that effects are a better abstraction. And if more people were using effect-oriented programming, then maybe we wouldn't need to generate so much crap code, that we'd have a better foundation of abstraction to build on top of. And certainly the LLM can help me generate effects oriented code. But I hope that as an industry, we continue to take steps towards better abstractions, as well as the tools that help us to actually write the code. And I don't know if things are necessarily going in if the gravity is going in that direction or not.
I
But
mean, there's with the whole vibe coding um, style of just plowing code until it works, deploy it, ship it, and then never look at it again. I don't know. Maybe
yeah,
we'll see.
I mean, I think vibe coding can work, can be compatible with good abstractions, good compilers, good type systems, and be even more beneficial. So one of the things I've wondered about is if you took a base kind of foundation model, and then you built some knowledge around it of effect systems, get like specialized it to being able to like help you write a effect oriented code well, then I think like you've got a tool that's way more powerful than the AI slop that's going to get generated, for Python or JavaScript or whatever. It should be able to actually really increase your productivity beyond what can be done in the untyped, less uh, non-effect oriented ways of doing things. So I'm hoping that that'll be a kind of leaping innovation that I don't know who's going to do it, but somebody should be able to combine good abstractions, effect oriented programming, good strong static type systems with the LLM tools, and actually get us to a much higher level of productivity than we have today with the crap that comes out of AIs for Python code.
And maintain the safety of your code. Really, I mean, when you imbue the LLMs with deep knowledge about the abstractions that you wanted to include in your code, then you get. I mean, if you do this right, and I haven't seen a complete recipe for it, I'm certainly trying it myself on my own code, but I haven't seen a complete recipe for it. If you get the output or the productivity of the LLM with the safety of a good abstraction of essentially good ideas. These are what abstractions mean. They're the good ideas that are embedded in your code. So if you imbue the LLM with these good ideas and you make it spit out the output in the style that fits the mindset of your code base, then you get, I think, or I hope, the best of both worlds in terms of code volume and also the code safety as well.
That's right. And then there's going to be the agentic loops that the better your compiler error messages, the better information that can give to the LLM to help it then iterate to a better solution. And so I think all this stuff, what we hopefully will discover in this is that static types are good, effect systems are good, tests are good, and all of those things, even they help me be a better programmer without the LLM. They can also help the AI agent be a better programmer,
Mm-hmm.
and get to a working solution more quickly. And by working, I mean something that isn't just like, oh, it works once and then I can't refactor it because who knows what possibly is going to break, like all the things that we talked about earlier. But these things have helped me more quickly produce better programs. And so that should also be true for the LLMs. It's just that I don't know if we've fully kind of pulled those threads together yet in a way that really is combining the benefits. So as an example to this is if you look at a lot of the code that I write, I'm heavily using type inference.
Hmm.
And so in the text of my code, the types are not there, right? Like sometimes, but rarely. And so maybe in my function signatures, whatever. And so for the LLM, that's actually a downside to type inference, right? Like oh, I'm sending the text representation of this code over to the LLM, and now the LLM's missing a lot of information. But you've, I'm sure, seen in IntelliJ, you can get it to display the inferred types. Probably what we should be doing if we send code that it has type inference in it to the LLM is we should be sending the representation with the types
With
in
the
them.
types attached, yeah.
Yeah, but I don't think anybody's doing that yet. So it's just like of course the LLM is going to be able to do a better job if it has the types in it, and so I think that that's a low hanging fruit place where oh types and type inference hooked to the LLM is going to be a huge benefit to bringing those worlds together. So yeah.
Well, we'll see. How do you think MCP fits into the picture? You talked about how you put an agent to work in a repeated loop and optimize your code, run the benchmark. How do you think MCP is going to help in the general productivity sense?
Yeah, so quick overview on MCP. Anthropic created this specification for the Model Context Protocol, and this is an API for tools. And tools are things that in an LLM you can say, here's the tools that you have available to you, like get the weather. You can get the weather by calling this tool, and then when the LLM responds, it can say, "Oh, I need you to call this tool for me," and then your program that is doing all this can then make the tool call out to get the weather, and then put that back into the LLM, and then the LLM can look at the response and be like, "Okay, now I know what the weather is," which it wasn't trained on the current weather in Crested Butte, Colorado, but it can go fetch that and then integrate that into the
Hmm.
response. So MCP just creates a protocol around those tools essentially, and so it's great because now we have a kind of standardized way to expose tools to the LLM, and we can do it in MCP. That the transport is decoupled from the protocol, so we can do it over standard IO running on your local machine. We can do it over the network with currently server sent events over HTTP, but they're also working on a stateless version of the transport. So this is great. Now we're going to be able to much more easily plug things into not just our AI coding assistants, but anytime we use an LLM for something, we can do tool calling in a standardized way. So I think there's a lot of really good things to what MCP is doing. There's also some smells of this being like the promises of SOAP and UDDI and
Hmm.
some of the things that we I don't know, probably 20 years ago we're like, oh, web services and you're going to be able to like do all these things, and then it never
Call
really
arbitrary
came to
functions and
fruition.
whatever.
Yeah, yeah. So I think there's some valid worry that there's that we're repeating some of the mistakes of the past here, and we'll see how it goes. But I think for me, I'm excited that the AI code assistants, many of them are now adding MCP support, and so then I have an extensibility uh, lever that I can do the things like we talked about earlier, where if I want to tweak something in my AI code assistant, MCP gives me one lever to do that,
Hmm.
that I think will make these tools even more useful and more capable. Uh, like I don't know, maybe I need to write a MCP server that will take a code suggestion and then reformat it into James code, which is different than what the rest of the internet writes, that could be an MCP server. So yeah, I think I'm excited about the potential for how I will use MCP servers in my flow. Like the profiler case was another one that could be interesting. It's like, yeah, like the LLM can't by default run a profiler on something, but I could provide an MCP server that could do that and do it automatically. So yeah, I think there's a lot of um, potential that this is opening up. The the MCP is pretty clearly like one at this point. Like it is like sure there's some deficiencies to it, but the how quickly the support around MCP exploded, I think says that this is solving, maybe not solving in the best way, but solving a problem that we have today in a way that is maybe not the most ideal way, but is sufficient for getting us to this next level. Um, there's already like thousands of MCP servers out there, and this spec was just announced at the like 3 months ago or something. So 3 4 months ago. So the Spring has support, Kotlin has support. I haven't looked to see what the state of MCP protocol stuff for Scala is yet, but I'm
Uh,
sure somebody's working
yeah, the
on it.
support for Scala and LLMs is uh, I don't know, a bit deficient at the moment. I mean, we are kind of using um, the raw knowledge that the most common LLMs have, and
But for
it's
MCP specifically
for
in Scala,
MCP
I don't know.
specifically. I'm not sure. I don't know of a good.
Yeah,
Um, I mean, I
yeah,
think the Virtuous Lab team in that's working on the Scala compiler. This is the team that has the most resources allocated to the Scala compiler. I think they're at least thinking about integrating something like that in the Metals uh, language server. So
nice. So yeah, it's exciting how fast it's moving. My biggest uh, gripe about MCP was that it didn't really bring the ideas of effects and functional programming to that world of MCP. So just as an example, I I may want to know in my agentic system, whether it's an AI coding assistant or something, some enterprise system that's using agents and LMs and MCP. Um, I may want to know when I call a tool, is this a idempotent?
mhm.
Like, I want to know the effect properties of this tool call. Is this going to mutate something? Can I call it more than once? Can I retry it? Like, is this a potentially destructive action? Like one of the things I love in functional programming is that we try to represent those things in hopefully in types, but we try to represent them through uh, what's the right word for it? Like we algebras, but like calculus. Like we try to like take these concepts and
Mhm.
try to convey them in a way that then we can reason about. And of course, like MCP, I doubt that the people that authored it are familiar with algebras and programming algebras and calculuses and effects and some of these concepts
Nor
because they certainly.
is the audience mostly aware of that these sort of properties. I mean, the
Yeah,
effect mindset is not that popular yet, and so I'm not expecting neither the authors of the protocol nor the audience of it or the consumers of it to be too much aware of this.
yeah, yeah,
Where do you
exactly.
think you are? Where do we? Where do you think we are? Where do you think we are in terms of the hype of LLMs and MCPs? And that are we still on the very steep ascending slope? Are we in for a disappointment? Where do you think we are there?
I fluctuate on that. Sometimes I'm like, oh, we are so high up on this hype cycle, and we're headed quickly towards the trough of disillusionment or whatever it
Hmm.
is. Like, and then other times I'm like, we may still be at the beginning of the climb to what these tools can do. So I don't know. I kind of go back and forth. It kind of depends maybe on um, at least with AI coding assistants, it depends on how good of an answer it gives me, or like how sometimes I'm just like shocked, like, oh my god, that was amazing and so good, and
Mm-hmm.
other times I'm like, you were so far off of what I wanted. um, and so I don't know, it's, I guess I go through these like ebb and flow, or like sometimes I'm like, oh my god, I'm going to be replaced tomorrow, and other times I'm like, I'm pretty sure I have a job for a long time because of the slop that I see. So I don't know. What do you think? What's your answer?
I
I'm curious
definitely
what you think.
oscillate between both as well. I mean, certainly for Scala, it's been more of a miss than a hit. More, I mean, less so for recent models. So Claude works pretty great for me if I give it very clear instructions. I mean, if I give it clear instructions and with a very detailed description of what I want, what I needed to be careful with, that sort of thing, it produces really great results. And my code is like, I don't know, subjectively, I haven't measured it, but I feel like I'm at least 2 or 3 times as productive in terms of code
Yeah.
writing. Um, and the code looks as if I wrote it. So it's certainly my style because I spent a lot of time in the prompts describing the kind of things that I wanted to be careful with and so on and so forth. So
Mhm.
a bit recently, I'm starting to like LLMs for development, but in like recent, even half a year ago, I was still writing most of my code myself.
Yeah.
Um, yeah, so I think that's a sign that, at least for me, that's why I was curious to hear your thoughts on it, uh, because LLMs are only starting to become really great and really useful for me. I think we're in the ascending phase of the hype cycle, but
Yeah.
I was very curious to hear your thoughts on it.
Well, and I think we haven't totally figured out all of the interaction models that are the best ones or the right ones around this, because we now have agents, so you can you like set the LLM free on a task and just have it iterate until it figures it out, and that's the agentic one. And that one, I think we're there. There's some good stuff happening there around the agentic flows. Um, so I think that's one interaction model that's kind of emerged, and you can do this in your IDE or on the command line. Um, but then there's other interaction models that I'm curious about, like one of the there's obviously like the chat, like asking questions and all that, which is super helpful. Like I used to ask Google a question about some code thing I don't understand, and then I'd have to open up like 100 tabs
Yep.
in my browser and then read through all those things and then try to get to an understanding based on all those things I read, and then go into my IDE and actually try something. And now I'm just in my IDE asking questions, and it's doing the like 100 tab thing for me
Yep.
essentially,
Essentially.
and then giving me the distilled answer, and I'm not even leaving my IDE anymore, which is I love. And so that's been huge for me, for that kind of explorative understanding piece of what I'm doing. Um, I what's interesting is the like Copilot and some of the other ones, the like the feature that they came out with that was the interaction model was the multi-line code suggestion
Hmm.
model, and I don't use that at all, because for me, like it generally, uh the challenge is not writing those lines of code. It's the thinking that I have to do to define my types, define the operations on them. And so I do that thinking not with the multi-line suggestion, but by actually, typing. And then maybe I get the thinking done, and then I am like, okay, the now that I've defined the types, I've defined the operations, now I can have the LLM like fill in the more
Yeah. I
boilerplate
mean,
oriented parts,
the
but I'm
software
going
is
to
just
ask it to
thinking,
do
really.
that. Yeah, exactly. And all that to say, I don't really use the what was the initial interaction model with the LLM, which is the multi-line suggestion. Essentially, I don't use it. It was not a useful thing in my workflow, but I'm also using generally low boilerplate languages and frameworks.
Hmm.
And so if I was writing JavaScript or Python or Java, then maybe that feature would be a lot more beneficial because there's a lot more boilerplate to the code. So I guess we're still, I think, figuring out what the right interaction models, uh, what those look like, how and why and when we should interact. So I think in that terms, it's still pretty early days to like the interaction models are still heavily evolving. And then of course we throw MCP in, and how does that impact those interaction
Yeah, it's
models?
like multiplying
Um,
everything.
yeah, exactly. Yeah. So it's fun times.
Yeah, I mean, definitely. Success is not guaranteed, but fun is always guaranteed. um, I
I'm
want
having a
to.
blast writing code, unless I'm writing Spring Java code and beating my head against my desk because I can't figure out, and my AI agent can't figure it out, and nothing can figure it out. So I'm just gonna have to like actually go ask an expert what's what's going on. Is
Yeah, I wanted
be the
to ask
result.
about it because look, I wanted. By the way, I want to be respectful of your time. I know we're coming up on the initial schedule for wrapping up the conversation. Do you happen to have more time, or
I,
are we
I do have more time, and it's so fun to talk to you, Daniel. So we could
awesome?
just
I
do
feel
this
the
all
same.
day.
All right. Yeah. Well, in that case, I wanted to ask about the kind of skills that you think are still relevant or even more important in the age of LLMs, because you were talking about uh, asking an expert. Yeah, I mean, it's the fallback solution to pretty much everything. You ask somebody who actually knows the stuff to fix
Yeah.
the code. How do you think about this in the age of LLMs and spitting out a lot of code that you don't necessarily have to understand? I mean, if you're a software engineer and you have a deadline and you have to push a feature or a bug fix or whatever, ask LLM, spits out a bunch of code. It looks kind of nice. The tests seem to pass, which are all generated by the LLMs, by the way. Um, the tests pass. The feature seems to work. Smoke testing works. You ship it. Um, but then you get burned in production. Um, Another use case, you spit out a lot of code. The code base becomes enormous. It's becoming a huge blob that you cannot really maintain because you haven't actually put the time to understand. These are just two examples that are, I'm pretty sure, that
Yeah.
are going to become more frequent in the age of
Oh, this
LLMs.
is already happening
Yeah,
for sure.
for sure. So, how do you think about keeping some timeless skills or important skills for a software engineer, at least the ones coming up into the industry at this moment, that that you think are going to be important?
Yeah, I mean, I think it's everything we've already said. With one additional thing I'll add, but abstractions are good because you're totally right that whether or not the AI or a human generates the code, we probably should understand it, and understanding is easier with higher level abstractions. And so using effects is a great abstraction so that we can write more concise code that is more direct to the problem that we're trying to solve. So, like going back to the race example, of course, I should be able to do effect.race another effect, and that's very clear
Hmm.
what I'm actually trying to do. But if you look at other languages and frameworks, like we'll just pick on Java for a second, the basic race, it's a lot of code that is very far away from the problem that you're actually trying to solve, which is I have an effect, race it with this other effect, give me the result back, give me the winner back,
Yeah,
and
and you have
cancel
to
the
think a
loser,
lot of
right?
about the internal state of the 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 stuff that
Yeah,
is racing, and you have to keep that in your head.
That's right. And if the LLM has created it, then you have to parse through and try to understand what is this thing actually trying to do. And so we call this what, like expressiveness. Like the more expressive our code is to the problem that we're actually trying to solve, that's a good thing. And having good abstractions allows us to do that more effectively. And so yeah, like I I do hope that we will not just rely on LLMs generating a lot of code, but direct the LLMs to generate concise code based on good abstractions so that yes, when the human has to read that code and understand what it's doing, that process is actually easier. Because to your question, we as humans, we are responsible for what goes into production as developers, and we can't hold the AI responsible. Like that's silly. Like it's a human that ultimately is going to be responsible for something running in production. um, and so we as humans should understand the code that is going into production. And that is a skill that we will still need to have as developers. And there's many different facets to how we understand code, obviously, like type systems and effects, and there's many ways, abstractions, like all the things we've talked about help us to get to better understand. But we got to tests, like good tests are a great way
Hmm.
to understand what code is trying to do. So yeah, so I think those skills continue to be important. Somebody's got to be creating good abstractions. For all my picking on Spring, it is for many enterprise developers a better abstraction than the alternative, and the Spring folks do a great job of like creating an abstraction that is actually generally really useful and helpful. And so some really smart people, we need them to continue to come up with the good abstractions. And so yeah, Zio being another one, but obviously many like abstractions. Often you need really smart people to come up with good abstractions. I've yet to see an LLM invent a new abstraction that
Unless
was
directed
that
by
was
somebody who already
really
has the
good.
good idea.
Right, exactly. Like certainly somebody, a human, can come up with that good idea. Like Zio, we are not at the point with AIs where Zio could have been invented by an LLM, right? Like that
That's an
was
interesting point. Yeah.
pretty novel and took some really smart people to invent and evolve and get a working abstraction. So we certainly still need those developers that can do that. That's not me. I'm not that smart. I'm not that that kind of developer.
I would
But
beg to
thankfully,
differ, and many
we
people would
still
beg to
have
differ,
these
but
like smart people that are able to come up with these abstractions. So I'm a great user of the abstractions. I'm not a great inventor of abstractions, but it's different skill sets certainly. So then the other thing I wanted to touch on related to this was, I think as we continue to move forward in this AI world, one of the things that's going to be really important is determining how we validate what working means.
what do you mean?
And uh, how do we know that our program works? Let's just imagine a world where uh, all that I have to do as a developer is write a really good test. And if my test is sufficient, it covers more than a test. I have to write my data type, my interface of what, just an interface defining what the functionality on my my objects are, and then I write the test. Maybe there's a world where that would be sufficient information to then derive the working program that actually use the data types, implemented the interface, and then satisfied all the tests. So let's imagine that's a future mode that we could work in. Then the challenge becomes, how do I sufficiently write that test? And this is where I've been exploring formal verification
Hmm.
languages. Maybe a formal verification language is the way to sufficiently write that test. And then all I have to do is
Generate the code that
define
passes
the
that.
exactly right. And so that's where I've been exploring languages to do this. So the Lean is one of the
Mm-hmm.
primary languages that I've been exploring. The syntax is a lot like Scala, so it's pretty easy to learn, which is
Art
awesome.
Nadersky was talking about it.
Uh,
Yeah. Mm-hmm.
yeah, and so and then I discovered that there is a Scala variant that does some amount of formal verification as well. So I need to dive a little more into that. I forget the name of that one, but there's this whole space that I think has been dominated by mathematicians and super smart people that are writing these languages for formal verification. And what I wonder is this going to like pull down into the world of a normal developer like me, where I'll be able to utilize formal verification to define the specification and then derive the implementation that fit, have the AI derive the implementation that actually passes the formal verification. So I don't know. That's part of what I'm interested in seeing how all that stuff plays out.
I am very curious. I mean, you've talked about a lot of things that you've been exploring. How do you find the time to to learn and study all these things?
Oh, I love learning. I love programming, and so luckily I've got a job where I get to learn and do programming, and yeah, so it makes it super fun. And then I get to help teach others about these things that I'm learning, and so yeah, I'm incredibly fortunate that I'm in a setup that allows me to spend time um, you know, learning new things and exploring lean and Daphne's another one that I've explored a bit. Another, it's not quite formal verification, but yeah, so fun that and then I like thankfully we live in this digitally connected world where I get to like learn from people like you and see your great content, and so yeah,
Thank you.
like it's what a fun time to learn in. Like, when I started programming, we didn't have this. We didn't have, YouTube and content creators and super
We
smart
have
people
books at
teaching
most.
other people. We had to go to a bookstore and buy a book on, pull it off the shelf and then sit and read the book. Like we just are in such a fun time to learn and grow, and the opportunities are just endless for how we do that now. So, and then we get to teach others too, which is super fun.
Yeah, I can definitely vouch for that. I mean, teaching is uh, super meaningful and fun, and it also sharpens my own skill as a developer because when I have to teach somebody, I have to be 10 times as careful as if I was with my own code because whatever I teach gets multiplied into
That's
the
right.
lives and into the production code of other people. So I have to be really careful about what I talk about.
Yep. Yeah, it's such a good like forcing function for
Yes,
me.
definitely to
Is like
learn
if
really
I'm going
well.
to do a presentation on something, like usually what happens is I submit a CFP to a conference and it's like this idea, and then it gets accepted and I'm like, "Oh, now I got to go actually learn that thing." And so it has become a fun forcing function to like force me to like have to actually learn this thing, because if I'm going to get up on stage and teach other people about something, I should probably know it pretty well myself. So, but often I submit the CFP not actually knowing what I'm in, I don't actually know the topic fully, and so then I have to do a bunch of research and learning.
This is an important tool, and I use it myself. I mean, when I create a course or even with presentations, I had pretty much the same technique for a couple of conferences that I spoke about. I submitted a piece that I submitted an idea that I particularly found interesting, and when I was accepted, I was like, "Oh, great! This is a great
Yeah,
idea." But now I have to like make it real because I never actually put it on paper to see how that thing
that's
would
right.
look like. So I
Yeah,
found myself with like 2 weeks within 2 weeks of the conference, frantically making that idea real, and I found
Yep.
resources within my brain that I never thought were there.
Yep. Yep. Totally. 100% done that many times.
This is a nice segue into conferences because I was curious about your. I mean, you have obviously lots of experience speaking on various stages at programming conferences around the world, and I wanted to ask about your interest in conferences. Why do you do it?
I think it's what we were saying. Like I do enjoy teaching things, and in part because then it forces me to learn. But then there's just a lot of enjoyment that I get from helping developers learn and grow. Like it's so fulfilling for me to like I think my pinned tweet right now is something along the lines of like I don't need to make myself a 10x developer.
Hmm.
What I would rather do is help, I don't remember the numbers, 5 developers become 2x developers or something. Like I would rather invest in others, like scale through others and
Yep,
help others level up than try for, like, I'm not ever going to be John DeGoes. Like John DeGoes is a really amazing developer. I'm not going to be him. But what I can do is help many other developers hopefully get better at what they do and more easily create better programs. Like that's the thing that just brings me a lot of joy. And it's kind of self-serving because I don't know about you, but I encounter about 1,000 bugs a day in the systems that I work with. Whether it's my car, I've got a great car. It is buggy.
yeah,
Like it is, like, it's crazy, but
I
my
understand.
car has a ton of bugs. And like I want software to be better because I use software.
Yes,
And so it's like self-serving also. Like I'm very disappointed generally with the quality of software that I interact with. And
I often get
I
this feeling. Yeah,
selfishly want software to be better.
yeah. I often see myself having. I mean, even kind of important apps like banking and stuff, and they freeze or they crash or uh, a
Yeah.
button isn't working. Like, come on, this is supposed to be important software. It makes me hate software sometimes, but it
Yeah.
also energizes me to help make software better through others, as you were speaking.
Exactly.
So yeah, this is
Yeah.
definitely a motivating factor for me as well. Um,
Yeah.
and what I mean, in a conference, I mean, you spoke at on many stages. What do you think, from your perspective as a speaker, what makes a great conference? Not just like a good one, a great one. What does that make for you?
Yeah. There's a huge variety in the conferences that I've gone to and go to. Um, so we, a couple weeks ago, had the Winter Tech Forum up
Hmm.
here in Crested Butte. Bruce Eckel puts that together, and it's a small conference, but it's all open spaces. We have great discussions, learn from smart people, and it's kind of defined as the hallway track. A conference that is only the hallway track is kind of the Winter Tech Forum, and so this is just a fun story from Winter Tech Forum this year, so just a couple weeks ago. On Monday, so the conference runs Monday through Friday. On Monday, we did a session about MCP and
Hmm.
agents and agentic stuff. And I was not really leading because, like, there's not really a leader in the discussion. It's just as a discussion, but I was providing some of the things that I'd learned about MCP and building agents in this group of people, and people were pretty interested. Like, oh, well, I want to build agents. I want to build MCP. But then I had to go to Atlanta for the DevNexus conference, so I missed the Tuesday, Wednesday, Thursday of the Winter Tech Forum. And I get back Friday on the last day, and everyone had spent all week building agents and building MCP servers, and I was so
Wow.
stoked to like oh, it's like I wish I could have been there to build with them. But everyone, all the people had built something like agentic and something with agents, and like, oh, it's so cool to see, like, okay, this like fun discussion that we had about using LLMs and building agents and building MCP servers then led people to like spend the week learning how to actually do that. And so that was super fun to see. So yeah, that conference is definitely on a it's a different type of conference than most of the other ones I go to. Um, Last year I got to go to LambdaConf, and that was had so many amazing interactions at that one just because
Hmm.
there's so many smart people there. I never went to Strange Loop because I felt I wasn't like cool enough or smart enough to go there. But obviously, like Strange Loop is where all the like all of my heroes hang out. LambdaConf is, I think, mostly that, and so I got to hang out with and learn from so many smart people at LambdaConf last year. That was really fun. Fun story about that one. I was I was on my way driving to LambdaConf, and I was listening to Richard Feldman's podcast on with Nathan Sobo, uh, the one of the founders of Zed, the IDE
Hmm.
Zed. So I'm listening to this episode on my way to LambdaConf, and then I get there, and Nathan is at LambdaConf just hanging out, and so I spend the whole like 2 days just like hanging out with Nathan, who's like also one of my heroes, and so I'm like hanging out with Nathan, and I'm like, how cool is it? Like, listen to the podcast. I had no idea you'd be here, and then I meet you, and then I build this relationship with Nathan and get him on my podcast. And so that was super fun. It's like I do like meeting my heroes, like you and
Wow,
Nathan,
I'm so
John,
flattered.
and
W-
no, you really help develop so many developers level up and teach them so many good important things. So
This is the
you're
biggest compliment
definitely
that I've
on my
received in a
hero
while. Thank you
list.
so much.
But yeah, so fun to like go to conferences where you can meet your heroes um and generally it's the heroes in our industry are amazing people and smart, and we have so much to learn from, and they usually like want to help others learn. So yeah, I guess that's a recap. Conferences like that's the best part for me
Yeah,
is like getting to do that.
similar for me. I was curious how you felt about it. Um, it's definitely the meeting great smart people that are also willing to help you or help. I mean, there's a vibe in a good conference where all of us help each other grow and learn and be better developers and better contributors to the world of software, because a lot of the world relies on software. So it's kind of like a shared responsibility um,
Yeah,
to help each other grow. And yeah, likewise. I mean, when I got to my first Scala conference and met Martin Odersky, my Scala hero, and probably everybody's Scala hero,
yeah,
I felt a very similar feeling, and it's
yeah,
definitely a good vibe. And if you have a conference that, as you said about the winter one, and it's where people start building stuff, and you have this energy of constructive people putting in all their efforts and on all their knowledge into learning and also making useful stuff. That's a jackpot. I one
yeah,
of my
yeah.
I mean, I keep daydreaming that I'm going to be able to organize such an event myself, but I don't know if that's ever going to come to fruition. Might
Nice. Oh, I'd love to go out for it. So keep
I
keep
don't
me
know, man.
updated.
We'll see. Yeah.
Yeah.
So James, it's been so much fun, and we covered a lot of ground. Is there anything
Good.
that you would like to share with my audience? Maybe a thought or a piece of advice or anything before we draw this conversation to a close. I want to be respectful of your time, and we went over the scheduled time. So, uh,
So fun to talk to you. Yeah, and I do really appreciate all that you do to help developers grow and learn. And so yeah, no other thoughts, but just thank you for teeing up this conversation because it is so fun to have these conversations. So yeah, appreciate you and appreciate this opportunity.
thank you, James. Thank you so much for coming. And for everybody who's listening and watching, we're going to have links to everything that we discussed. And until next time, thank you for watching, and I'll see you next time. Thank you, James.
Thanks.